Fuel tanks are another one of those areas on model trucks where the kit provided parts are a great starting point for added details. The Transtar 4300 kit takes the usual approach of making the fuel tanks into halves with the majority of the details molded in. The right side fuel tank in the kit matches the truck I'm modeling rather closely, with the main difference being the fuel cap on the model is located near the back of the tank, and on the real truck it was closer to the front. This picture, from an online for sale ad, shows a closer view of a similar tank, with the fuel cap location and also the location of some of the basic fittings for fuel gauge, fuel line, and return line. Parts of both the bottom and top steps are molded to the fuel tank half, and although I am going to use the bottom step, it was removed from the tank so the holes could be drilled out at the workbench. Molded in ledges representing the lower portion of the top steps are also removed, and the fuel tank halves glued together. Trying to preserve molded on details such as tank bands is very difficult when filling and sanding the seams. So I take the approach of sanding everything smooth. This takes away any of the unwanted molded on detail, and it also deals with the chrome plating. For this rough sanding operation, 120 grit paper is used. A super smooth surface isn't necessary because the tank will now be covered with a 10 thou styrene wrapper. Cut this piece slightly over length and glue one edge down as a starting point. Form wrapper around the tank, secure with elastic bands, and mark both ends to determine the cut line. Unwind the wrapper and cut to length, and then recheck the fit. Once the wrapper is the correct size, wrap it back around the tank and secure with CA glue, elastic bands, and a piece of balsa wood along the seam line. Some glue will likely creep between the wrapper and the balsa wood block, and although it looks messy when the block is taken off, this is easily sanded smooth. Clean up the seam line as required, and finish sand the wrapper and the ends with finer grades of sandpaper, finishing with 400 grit. Using the styrene wrapper is much easier than trying to fill all the different holes on the tank, and the only seam that's left is this one, which will be located against the frame in a non-visible area. The increase in diameter of the tank by adding the 10 thou styrene wrapper is not noticeable on the finished model. With the basic tank prepared, now we can get the brackets ready. The kit's fuel tank brackets are nicely done. They just need some cleanup of ejector pin marks, and the upper mounting lug will be removed, retaining the bottom one. Assemble the two parts for each bracket, and fill any gaps in the bottom locator pin hole, as this area is below the frame on the finished model and will be visible. One minor issue with the kit is that all the fuel tank brackets are identical, but there's a step in the frame, highlighted in red, which measures about 20,000ths of an inch in depth. To keep all the fuel tank brackets in proper alignment, shims are cut from 20 thou by 250 wide styrene strip, holes drilled for the mounting pins, and installed on two of the brackets. With brackets glued in place on the frame, the fuel tank is set in place temporarily to mark the location of the locator pins. A highly sophisticated clamping system using equine braiding elastics and an AMT metal axle holds the fuel tank tightly in place against the brackets, while the mounting pin locations are transferred to the wrapper. The same braiding elastics are used to hold a piece of 250 by 250 styrene angle, which provides a straight edge to ensure that all three holes are in alignment. Drill 1/16 inch diameter holes at these locations to match the mounting pin sizes. Many of the pictures I found online of Transtar 4300 fuel tanks showed these two rounded projections on the ends. This is the end of the fuel tank referenced earlier, and here is a different truck showing the same rounded projections on the forward end. These are easy to add by cutting styrene discs and laminating to the ends of the fuel tank. Cutting clean discs of the required size is easily done with this compass cutter tool. Tape the styrene sheet down to the work surface to keep it from moving around while cutting. Sizes for the discs were estimated based on the photos and proportions. Discs were laminated to the ends of the tank, and fittings were constructed using styrene discs and strip for fuel return line, fuel gauge sending unit, fuel line, and a piece of 532 brass tube was installed for the filler neck. Here's a close-up look at a real fuel tank strap on a 4300. I'm going to take a slightly simplified approach on the model using 10 thou by 80 thou styrene strip for the strap and 125 channel for the rubber padding. An 0.32 diameter hole is drilled in the bottom end of each bracket, being careful to keep the drill square to the surface and not break through the bottom. The 10 thou by 80 thou strip for the strap is glued in place on the top of the fuel tank bracket. Although this doesn't replicate the T-shaped bolt threaded into the bracket on the real truck, it is convincing enough in this relatively low visibility area under the cab. With the straps in place and left extra long, the fuel tank is threaded into place and then glued to the brackets. To trim the legs of the 125 styrene channel down to a more realistic size, a piece of 1/64 by 332 brass strip was set inside the channel and the whole assembly taped down to a flat surface. This provided a thickness gauge so that the legs of the channel could be sanded down and kept to a consistent measurement. Pieces were cut the required length and formed around an X-Acto knife handle to give them a slight degree of pre-bend to better fit the curvature of the tank. Glue the bottom end of these channels in place first and use dressmaker's T-pins inserted into the 0.32 holes in the tank brackets to hold them down while the glue sets. Here's another view of the same operation. Again, at this stage, the 10 thou by 80 thou strip for the fuel tank straps is left extra long. Use the strap to align the top of the channel and hold in place with another high-tech clamping device, balsa wood blocks inserted between the cab floor and the channel. Sometimes the parts don't cooperate, like the front channel here, which broke when the solvent cement was applied. If this happens, it's not the end of the world. Just remove the offending piece. Cut and pre-bend a replacement, glue it in place, and carry on. With the channels installed simulating the rubber padding, pull the tank straps around, mark, and cut to length. Glue the straps into the channels, and again use dressmaker's pins in the 0.32 holes at the bottom of the brackets to secure the bottom end of the strap down. The last pieces to make and install are short pieces of 30 thou styrene rod with one end flattened and cut to the approximate length shown here. Finished length works out to about 5/32 of an inch. Glue these in the drilled holes with the flat portion against the strap. This simulates the bolted end at the bottom of the strap, and again it's not an exact replica of the prototype, but it's convincing enough in model form. In fact, on the Transtar, this step is optional because this area will be covered by the step later. With fuel tank installed and straps completed, we're at the end of part 1. Part 2 will cover the steps and the fuel cap. This, of course, is only one of many approaches you can take. I like using the styrene wrapper as an alternative to try and fill and sand a bunch of holes and seams, and adding freestanding parts after makes it easier to replicate a specific truck. Thank you for watching all the way to the end of Part 1. Part 2 will be coming along in the near future.